Hello students, we are studying Laplace transforms. This is lecture number 2 on Laplace transforms. In the previous lecture we saw the basic definition and the Laplace transform of some standard functions. In this lecture we will study the theorems on Laplace transform. So firstly, the first theorem is the first shifting theorem. Okay, so we will write the statement for first shifting theorem. Okay, try and understand this statement. Okay, the statement says if L of f of t is f of s. Okay, L of f of t is f of s means what? If we have any function of t and its Laplace transform, we know that will be what? F of s. Okay, then L of e raised to minus at into f of t is equal to f of s plus a. Okay, now what is this f of s plus a? This f of s plus a will be calculated using f of s when this s is replaced by s plus a. And what is this f of s? F of s is nothing but L of f of t, Laplace transform of f of t. So in this Laplace transform of f of t, you need to replace this s by s plus a. Now see what it means. If you have the Laplace transform of f of t is equal to f of s, and if you will multiply this f of t, if you will multiply this f of t, that is this f of t, by this term, what is the term? E raised to minus at. Okay, for example, suppose I have the function like sin at and this is like f of t. Okay, if I will multiply this sin at by some exponential function like e raised to minus 2t, then what will be its Laplace transform? And that gives the first shifting theorem. Okay, so that's it. If f of t, if this f of t is multiplied the exponential e raised to minus at, then what will be the Laplace transform of it? Okay, means what? If you will insert, okay, e raised to minus at here, okay, here if you will insert this e raised to minus at, then what will be changed in RHS? In this s will get replaced by s plus a. What is this a? This a is a coefficient of this t. Okay, that is what they are saying. If you will multiply this f of t by e raised to minus at, then what will be this? This will be f of s plus a. Okay, and how this f of s plus a will be calculated? It will be calculated from f of s. In that f of s, you need to replace this s by s plus a. Okay, again, what is this f of s? F of s is nothing but L of f of t. Okay, so you need to calculate L of f of t, and in that L of f of t, replace this s by s plus a, and that will be the Laplace transform of e raised to minus at into f of t. Okay, that's it. That says the first theorem. Okay, for example, if I want to calculate for this same function, suppose I want to calculate Laplace transform of e raised to minus at, then what will happen? L of e raised to minus at sin at. Okay, now you need to identify what is f of t. Okay, so in this case, what is f of t? Sin at is f of t, and to find its answer, what we need? We need f of s, so that in this f of s you will replace this s by s plus a. Okay, this is a. Okay, this a and this a is different. Suppose I will take this as b. Okay, this is what? B. Okay, so that you will replace this s by s plus b. Okay, see this, what is this f of s? F of s is nothing but, by the statement of the theorem, f of s is nothing but L of f of t. And what is f of t? F of t is sin at. F of t is sin at, and if you will take Laplace over this f of t, that will be Laplace over sin at. And Laplace of sin at is nothing but a upon s square plus a square. Okay, so this is our value for f of s. Okay, so we got this f of s. What is this f of s? F of s is nothing but a upon s square plus a square, and in this s will get replaced by s plus b. Okay, so replace s by s plus b, so this will be a upon this s. Okay, see this s will get replaced by s plus b, so this will be s plus b whole square plus a square. Okay, so that will be the Laplace transform of e raised to minus bt into sine at. Okay, that is what the first shifting theorem says. Okay, suppose we want to calculate the Laplace transform of f of t equal to e raised to minus at into sine at. Okay, so what we need to calculate the Laplace transform of e raised to minus 3t into sine at. Okay, so to calculate this Laplace transform, see the process how to calculate it. Firstly, consider the f of t. What is f of t? Sine at. Okay, find out its Laplace transform. What is the Laplace transform of sine at? That is a upon s square plus a square. Okay, now insert the term. What is the term? E raised to minus 3t here. Okay, so what will happen? This will be e raised to minus at into sine at. Okay, and what will be changed here? So this is our f of s, is it? So in this f of s, what will happen? What is f of s? A upon s square plus a square. In this f of s, what will happen? This is 3. What will happen? This s will get replaced by s plus 3. So finally, what we will see? This will be equal to a upon this will be s plus 3 square plus a square. Okay, so this is our final answer for Laplace transform of e raised to minus 3t into sine at by first shifting theorem. Okay, so hope it is clear. Again, if you see this example, you need to identify what is f of t in this case. Okay, so if you observe here, so what is f of t? F of t is t square. Okay, so firstly calculate Laplace transform of t square. Okay, and this 2 is an integer number. Okay, so what will be its Laplace transform? N factorial upon s raised to n plus 1, but n is 2, so this will be 2 factorial upon s to the power 2 plus 1. This will be 2 upon s raised to 3. So this is nothing but f of s. Okay, so after getting f of s, what you will do? You will insert this term. Which term? This e raised to minus at here. Okay, so what you will see? This will be e raised to minus 2t into t square. And what will be changed in f of s? So in this f of s, you need to replace this s by s plus 2. So what is f of s? F of s is nothing but 2 upon s cube, and in this replace this s by s plus 2. So this is equal to 2 upon s plus 2 to the power 3. This is our final answer. Okay, next example. Again identify what is f of t. In this case, this is first shifting theorem example. So this is f of t. So firstly calculate the transform, Laplace transform hyperbolic sine 5t. Okay, and we know what will be hyperbolic sine 5t. It's Laplace transform, that is 5 upon s square minus 25, 5 square. Okay, so this is nothing but f of s, is it? Now what you will do? You will insert this e raised to minus at here. Okay, so what you will see? This will be equal to L of, what is this? E raised to minus t into hyperbolic sine 5t. Okay, what will be changed in f of s? So in this f of s, this s will get replaced by s plus 1 because the value for a is 1. Value for a is 1 in this case. Okay, so that what is f of s? But f of s is nothing but 5 upon s square minus 25, and in this replace this s by s plus 1. So this will be 5 upon, this will be like s plus 1 square minus 25, and this is your final answer for Laplace transform of e raised to minus t into hyperbolic sine 5t. Okay, suppose we will take one more example. Now if you will observe, one change is there. What is e raised to? We have formula. What is the first shifting theorem we have? We have theorem for if L of f of t is f of s. Okay, then what? L of e raised to minus at. Okay, this is important. E raised to minus at. The coefficient of t is minus a. F of t is what? F of s plus a. This is our first shifting theorem. But this is for e raised to minus at. But in this case we have e raised to plus at. Okay, so we can transform this definition, this theorem to what? What will be e raised to minus plus 80 f of t. Okay, just replace this s by, instead of s plus a, we will replace this by s minus a. Okay, because the value for a is minus a in this case. Okay, so what will be Laplace transform of this? Okay, so what is f of t? Again, what is f of t? Cos 80. So Laplace of cos 2t is nothing but s upon s square plus 2 square is 4. So this is our f of s. Okay, so insert this e raised to 4t here. Okay, so what will be this? This will be L of e raised to 4t into cos 2t is equal to, so in this f of s, replace this s by s minus a, that is s minus 4, because the coefficient of t is not minus 4 in this case. This is what? Plus 4. So that we will replace this by s minus 4. So what is f of s? S upon s square plus 4, and replace s by s minus 4 in this case. Okay, so this s, numerator s will get replaced by s minus 4, and denominator s will replaced by s minus 4 square plus 4. This is your final answer. Okay, again we have the same kind of example. If you observe here, the coefficient of is not e raised to minus 3t, it is e raised to 3t. Oh, okay, so again, what is f of t? But f of t is t raised to 4. So firstly we will calculate this Laplace of t raised to 4, which is what? 4 factorial upon s raised to 4 plus 1. Okay, so this will be 4 factorial is nothing but 24 upon s to the power 5. Okay, so this is what? 24 upon s to the power 5, and this is our f of s. Okay, so what will be next step? So replace or insert this e raised to 3t here. Okay, so what will happen? This will be e raised to 3t, but the coefficient of t is plus 3. Okay, so what will happen? In this f of s, this s will get replaced by my s minus 4. Okay, so this will be, what is f of s? 24 upon s to the power 4. Okay, and replace this s by s minus 4. So this will be 24 upon s minus 4 to the power 4. Okay, and this is your final answer. Next example, we will see what is the Laplace transform of this function. Okay, so firstly we will write the given function. The given function is what? We will write it like this. Okay, L of, you want to find the Laplace transform of 1 plus e raised to minus t into sine 2t plus cos 2t. Okay, by linearity you can write this as Laplace of 1 plus Laplace of e raised to minus t into sine 2t plus cos 2t. Okay, now we know the Laplace of 1 is nothing but 1 by s. Okay, and this term is the example of first shifting theorem clearly, and in this case the f of t value is this whole function sine 2t plus cos 2t. Okay, so we will say this as equation number 1, and we will try to find the answer for this Laplace transform using first shifting theorem. So in this case you need to identify what is f of t. So if you know, the f of t is nothing but sine 2t plus cos 2t, so take its Laplace transform. Okay, so by linearity I can write this as Laplace of sine 2t plus cos 2t. Okay, this will be like sine 2t plus Laplace of cos 2t. Okay, and Laplace of sine 2t is nothing but 2 upon s square plus 4, and Laplace of cos 2t is nothing but s upon s square plus 4. Okay, so this is nothing but our f of s. Okay, so once you will get f of s, what you will do? You will insert this e raised to minus t where? Here. Okay, so what will happen? What you will get? This will be like L of e raised to minus t into sine 2t plus cos 2t. Okay, what will be changed in f of s? In f of s, this s will get replaced by s plus 1, because the value for a is 1. But what is f of s? F of s is whole term 2 upon s square plus 4 plus s upon s square plus 4 and in this s will get replaced by s plus 1. Okay, so finally what we will see, this will be like 2 upon, replace s by s plus 1, so this will be s plus 1 square plus 4 plus s plus 1, in numerator also there is s, so s plus 1 upon s plus 1 square plus 4. Okay, so this is our answer for this term. Okay, so finally from 1, okay, from 1 what we can write, from equation 1 we can write what, L of 1 plus e raised to minus t into sine 2t plus cos 2t, okay, is equal to what is this, 1 by s as it is, plus Laplace of this term, okay, that is what, 2 upon s plus 1 square plus 4 plus s plus 1 upon s plus 1 square plus 4. Okay, so this will be the Laplace transform of the given function f of s. Okay, now we will see the next theorem, that is the second shifting theorem for Laplace transform. Okay, now in this case you need to remember the theorem first. Okay, so what says the theorem, we will write the statement for second shifting theorem. Okay, so statement also says, if L of f of t is f of s, okay, again same thing is happening here, if L of f of t is f of s, and also now in this case we have given some extra function, that function is f of t. Now see, there is a difference between this f of t and this f of t. This f of t is this f is small, and this f of, in this case this f of t, this f is capital. Okay, so if L of f of t is f of s, and we will define this f of t, the function, how to define this, suppose this function is defined like this, this is f of t minus a for t greater than a, and suppose this is 0 for t less than a, then this is important, then L of this capital f of t, okay, what we need Laplace transform of this f of t. Okay, and this will be given by e raised to minus as into f of s. Okay, and what is this f of s? This f of s is nothing but L of f of t. Okay, so to solve the examples over this kind of examples, see what we need to do. Okay, I will explain it again what it means, what we have given. Okay, this is like if and then statement. Okay, means up to this part we have given. Okay, up to this part things are given to us. Okay, and using these things we need to prove this. Okay, so this is the statement. Okay, so what is given to us? What is given to us? If L of f of t is f of s. Okay, if the Laplace transform of f of t is f of s, and also they have defined this another function capital F of t, that is what, f of t minus a for t greater than a, and this is 0 for t less than a, then if you will calculate, if you will try and calculate the Laplace transform of this f of t, then what the transform will be, e raised to minus as into f of s. Okay, and we know what is this f of s, this f of s is nothing but L of f of t. Means what, to calculate f of s we need f of t first. Okay, what is f of s is given, f of s is given L of f of t, means to calculate this f of t, f of s, we need this f of t. And how to get this f of t? This f of t will be calculated using f of t minus a. Okay, so how to get f of t? F of t can be calculated using this f of t minus a. Okay, what you will replace? You will just replace in this term, you will just replace this t by t plus a. Okay, see what will happen, this will be t plus a minus a. What you will get? You will get f of t. Okay, so again I am repeating what we need. We need a Laplace transform of which function? We need a Laplace transform of this function capital F of t. Now it is given by f of s. Okay, and you know f of s is nothing but what? L of f of t. Means to calculate f of s, what we need f of t. How to get this f of t? F of t can be calculated using f of t minus a. How? In this f of t minus a, replace this t by t plus a, so that you will get f of t, and then find Laplace over this f of t, that will be what? F of s. Okay, that will be in our answer. Getting me? For example, suppose we have the example like this. Okay, if L of f of t is to find the L of f of t, if you observe here, this is capital F of t, and the value for capital F of t is given to us, that is e raised to minus 4 t minus 3 for t greater than 3 and 0 for t less than 3, and we need to calculate what? We need to calculate L of f of t, L of f of t. Okay, and what is this? By second shifting theorem, this is e raised to minus as into f of s. Now what is this a? This a value for a is here. Okay, if you observe in the statement, okay, where is a? A is here. Okay, so value for, in this case, value for a is 3. Okay, so most important thing, what we need this f of s. Okay, we need this f of s, and how the f of s is given? F of s is given by L of f of t. Means what? We need this f of t, and how to calculate f of t? Using f of t minus a. And what is f of t? F of t can be calculated using f of t minus a. Okay, means what? F of t minus 3. Okay, what is value for a? Value for a is 3. Okay, so f of t will be calculated using f of t minus 3. In f of t minus 3, replace this t by t plus 3. Okay, but what is f of t minus 3? What we have given, f of t minus 3 value is what? E raised to minus 4 into t minus 3. Okay, so what we will do? We will replace this t by t plus 3. Okay, so what you will get? This will be f of, replace this t by t plus 3. Okay, and this minus 3 as it is. So in this also replace this t by t plus 3, so minus 3 as it is. Okay, so what you will see, this will be f of t, and this will be equal to e raised to minus 4t. Okay, so we got the value for f of t. Okay, so what we have now? We have f of t. F of t is what? E raised to minus 4t. Now once you have f of t, you can calculate f of s by taking Laplace on both sides. So Laplace of f of t is nothing but Laplace of e raised to minus 4t, and this is the exponential function, and we know by standard formula the Laplace of this will be s plus 4. Okay, so this is nothing but f of s. Okay, so finally what will be our answer from this? What will be our answer? L of f of t, this is capital F, L of f of t is equal to e raised to minus as into f of s. But what is a? A is 3, so this will be e raised to minus 3s into f of s. F of s is 1 by s plus 4. So this is our final answer. Okay, so this is how we solve the examples on second shifting theorem. Okay, next theorem, suppose next example we have. Okay, firstly write down its solution. What will be solution for this? Solution for this will be what? L of this capital F of t will be nothing but e raised to minus as into f of s. Okay, so this is our solution. Okay, I will say this as equation number 1. Now in this solution, what things we need? We need the value for this a, we need this f of s. Okay, so if you compare with this capital F of t with our statement, the value for a is nothing but pi. Okay, so one thing we got. What we need now? We need f of s. And how this f of s is given? How f of s is given? F of s is given by L of f of t. So to calculate this f of s, we need f of t. And how this f of t is given? F of t is given using f of t minus a. So what is f of t minus a in this example? That is sine of 2 times t minus pi. Okay, so you can calculate f of t using this f of t minus a by replacing what? T by t plus a. Okay, but what is a? A is pi, so replace this t by t plus pi. Okay, so in this, what you will get? This will be f of t replaced by t plus pi, and this a is nothing but pi. Okay, so what is this? This will be sine of 2 t plus pi minus pi. So what you will get, this will be sine 2t, okay, and this will be nothing but f of t. So once you will get this f of t, you can easily calculate f of s. Okay, so what we have got? We have got the value for f of t. Okay, so f of t is what? F of t is nothing but sine 2t. So taking Laplace on both sides, this will be Laplace of f of t. That is Laplace of sine 2t. Laplace of sine 2t is nothing but 2 upon s square plus 4, and this is nothing but f of s. Okay, so once you will get f of s, okay, so from equation number 1, so therefore from equation 1, what we know now, L of f of t, capital F of t, is nothing but e raised to minus as into f of s. But a is pi, so this will be e raised to minus pi s into f of s. F of s is 2 upon s square plus 4. And this is the final answer using second shifting theorem. Okay, now see this. To find the Laplace transform of this f of t, okay, and f of t is given, f of t minus a value is given to you. Okay, so again firstly we will write its answer first. Okay, so what will be solution for this? Its solution will be L of capital F of t is nothing but e raised to minus as into f of s. I will say this as equation number 1. Now what we need this f of s, and it will be calculated using f of t. But what we have f of t minus a, but value for a is what? 2. So this will be f of t minus 2. That is what e raised to minus 4t minus 2 given into t minus 2 whole square. So in this, replace this t by t plus a, but a is what? 2. So this will be, replace this t by t plus 2. So what you will get? This will be t by t plus 2 minus 2 equal to e raised to minus 4. Replace this t by t plus 2 minus 2 and this t by t plus 2 and this minus 2 as it is. Okay, so this will be nothing but f of t. And what is f of t? This is e raised to minus 4t. This 2 and 2 cancels, and what remains here? T square. Okay, so our f of t is e to the power minus 4t into t square. So whatever Laplace you will take for this, that will be our f of s. This will be L of f of t will be what? L of e raised to minus 4t, and its Laplace transform will be our this f of s. Okay, so find out its Laplace transform, and its Laplace transform will be calculated using first shifting theorem. Okay, so what we observe in the first shifting theorem, what is f of t in first shifting theorem? F of t is t square. So firstly find out Laplace transform of f of t, that is f of t square, that is 2 factorial upon s to the power 2 plus 1, that is 3, which is 2 upon s to the power 3. Now insert what? Insert this e raised to minus 4t here. Okay, so this will be L of e raised to minus 4t into t square. What will be change in RHS? This will be upon 2 upon s cube, and this s will get replaced by s plus 4. So this is nothing but 2 upon s plus 4 to the power 3, and this is our final f of s. Which f of s? This f of s. Okay, now from therefore from equation 1, what we get? We get L of f of t is equal to e raised to minus as. A is 2, so this will be raised to minus 2s into f of s. F of s is 2 upon s plus 4 to the power 3, and this is our final answer. Okay, after seeing the second shifting theorem, now we will see what is the change of scale theorem. Now change of scale theorem, we will write the statement first. So the statement says, if L of f of t is known to us, if L of f of t is known to us, that is what? F of s, suppose, then by change of scale theorem we will change the scale of this t. Okay, so instead of this t, what we will replace this t by at. Then what will happen? Then L of f of at will be equal to what? That will be 1 by a f of s by a. Okay, now see the change. What we have done, if you will replace this t by 80, what will be changed? This S will get replaced by S by A. Okay, and that is the change of scale theorem. What it means? Okay, now we know Laplace transform of sin t. Okay, what is Laplace transform of sin t? That is what? 1 upon s square plus 1. Okay, but by using change of scale theorem, we can calculate the Laplace transform of sin 3t. Okay, we have changed the scale, means what? This t is replaced by what? This 3t. Okay, so if you don't know what is the Laplace transform of sin 3t directly, and if you know the change of scale theorem, you can calculate Laplace transform of sin 3t using Laplace transform of sin t. Okay, so what they are saying, divide this. Now what is this? This f of s plus f of s by a. This is 1 by a divide it by a. Okay, and in this f of s, replace this s by a. Okay, so what you will get? You will get this is f of s by a. Okay, so what we need in this f of s. Okay, but what is f of s? F of s is nothing but L of f of t. Okay, and L of f of t is nothing but 1 upon s square plus 1. This is our f of s. Okay, so in this f of s, replace this s by a. Okay, or this will be equal to what? And divided by a. What is a? A is 3. So this will be 1 by 3. And what is f of s? 1 upon s square plus 1. And in this, replace this s by a. But a is 3. Okay, so this will be 1 by 3. Replace s by 3. Okay, this will be 1 upon s by 3 square plus 1. Okay, so this will be 1 by 3. Okay, and this will be, after solving this, what you will see, this will be as 9 upon s square plus 9. Okay, and finally what you will see, this as 3 upon s square plus 9. That is our Laplace transform of sin 3t. Okay, this is what? Sin 3t. Okay, so we can calculate the Laplace transform of sin at if you know the Laplace transform of sin t. Okay, for example, in this example, okay, what we need Laplace transform of sin at, means what? This t has changed its scale from t to at. Okay, and this is given to us. If this is given, okay, this is given means what? This is our f of s. Okay, so using change of scale theorem, okay, if L of f of t is what? F of s. If L of f of t is what? F of s. If you know this, okay, so what is f of s given to us? L of 1 sin t. L of sin t is given to us, that is what? 1 upon s square plus 1. Okay, and using this, what we need to calculate? You need to calculate L of sin at. Okay, so you will change the scale from t to at. So this t will get replaced by at. So this will be sin at. What will be changed in RHS? Divided by a. And in this f of s, okay, in this f of s, replace this s by a. So this will be 1 by a, 1 upon, this will be s by a square plus 1. Okay, and after solving this, what you will see, this will be 1 by a square upon s square plus a square, which is equal to a upon s square plus a square. Okay, this is known formula for sin at. Okay, suppose we will see one more example to find the Laplace transform of the given f of 2t. Okay, so what we have given? We have given L of f of t is given to us. Okay, what is that? S upon 12s minus 2s square upon s square plus 4 whole square. Okay, so what we are doing now? We are changing this scale to 2t. Okay, so this will be f of 2t. Okay, so we need to find L of f of 2t, and what will be the change here? Divided by a, that is 2, and in this f of s is s plus 12s minus 2 square upon s square plus 4 whole square. In this, replace this s by 2. Okay, because value for a is 2. So this will be equal to 1 by 2. Replace s by 2. This will be s by 2 plus 12 into s by 2 minus 2 into s by 2 square, okay, this will be equal to what? This will be s by 2 square plus 4 whole square. Okay, now solve this. Okay, so after solving this, what you will see, this will be 1 by 2 in bracket. Okay, now taking the LCM, okay, the LCM will be 4 in this case. Okay, the LCM of 2 and this is 4. Okay, so LCM will be 4. Okay, so this will be in the first term. This should be s square, s plus 12s. Okay, so whatever answer we will get from this, s plus 12s is nothing but 11s. Okay, in this case I can replace this by directly 13s. Okay, so this is nothing but 13s. S plus 12s is nothing but 13s minus this is 13, and this s will get replaced by s by 2 and this as minus 2. Still the LCM will be 4. Okay, so from this what you will see, this will be 2 into 13, that is 26s. Okay, minus, and this will be 2s square. Okay, upon this will be s square by 4 plus 4, and this will be whole square. Okay, and this will be 1 by 2 into 1 by 4. Okay, again still you can divide this 26 by 4. Okay, anyway this will be 26s minus 20s square upon this will be like s square plus 16 upon 4 square. Okay, and this will be 1 by 4 square will be 1 by 16, that will go up as 16 upon 8 in bracket 26s minus 2s square upon s square plus 16 whole square. Okay, so again you can cancel this 8 by this 16, this will be 2, and that will be your final answer using change of scale theorem. Okay, so this is how we solve the examples using the theorems of Laplace transforms. Okay, like we have seen the first shifting theorem, second shifting theorem, and change of scale theorem. In the next lecture we will study some more theorems. Okay, bye, thank you.